What's happening, folks? Geologist Philip Prince looking out over the Swiss Alps today. A little village down here in the bottom of the valley called Blatten has been in the news quite a bit the past week or so because it is being threatened by a really big rockslide or landslide event that is taking place much higher up on the mountain here above it. So the area I'm drawing in yellow there roughly represents where rockslide activity has been covering a small glacier with a huge pile of rock debris. And if you think about piling a whole bunch of rock on top of a big sheet of ice that's itself sitting on sloping rock a little bit more than a mile above a town, you can understand why this is a very serious situation. The concern is that all of this will fail very suddenly and send both rock and ice debris combined down the slope at high speeds. It would be acting more like a fluid, even though it's carrying pieces of solid material. And when it gets to the bottom of the valley, it has the potential to spread out very significantly and cause a lot of problems there. In addition to the rock slide activity that's pouring material onto the glacier, seen a lot of imagery that suggests that a larger area, which I've covered in red there, is actually sort of shifting down the mountain as well. So there's a lot of instability, and anytime you're looking at this mass of rock and ice in an unstable situation that high above a populated area, it's a cause for significant concern. Swiss authorities are not they're not unfamiliar with situations like this just because of the nature of the landscape in this area. But this one's a big deal just because of the amount of material, its height above the valley floor, and the fact that if it starts moving due to the slopes, it's going to go fast and undergo that sort of fluidization process. The Google Earth you're looking at here is older, so we actually don't see the effects yet in Google Earth. If you look right in the middle of the screen, there is a gray area on top of that small glacier that shows there's been past slide activity that has poured material out on it. But I was able to pull down some satellite imagery from the last month or so. Turn on late April there, and then I'm going to turn on May 18th. And I imagine that the darker color that you see there appearing is the result of some of the earlier stages of the slide activity that's going on right now. We'll outline that and then fade these overlays away, and it'll give you a sense of the actual point on the mountain where the problems seem to be starting there. So we got our outline. We'll fade that overlay, and there you go. Sort of right up above the top of the area that seems to have produced some slide activity in the past. That's the new top of the failure there. And again, some of the time lapses that are out are pretty frightening to look at because they give the sense that a much larger piece of the slope here is sort of slowly but surely trying to shift down the mountain. Now, how much of that is going to end up moving? I don't think anyone knows. I think there's some hope that smaller amounts of material may continue to move downhill and sort of take the edge off of the situation instead of just building up more and more load high on the slope there. But in any case, this would be cause for significant concern if you were below it and down slope. If you just look at the overall appearance of the mountainside here, you can get the impression that it's a pretty rough place, and it makes perfect sense that it's an area in the world that's going to experience a lot of rock slide and landslide activity. This one is interesting because it's first of all combining rockfall and landslide with ice. So it's like putting the rock and landslide material on top of ice. The ice is itself unstable, and both of them might end up failing together. And it also looks like, and this is just speculating based on Google Earth, it looks like the overall big mass of moving rock up there that I've been outlining in red, it looks like that may be developing on sort of a geologic boundary here that would be some kind of a contrast in rock type. I don't know that for sure. That's just what you get the impression of from looking at the landscape here. So what's up with rockfall and landslide in this part of the world? why does the land look like this and why is it so prone to instability? Here on the east coast of the US, stuff like this, it doesn't happen, right? We don't have the geologic conditions to produce it. But in the Swiss Alps, and in fact in any recently glaciated area in the world, you're always going to run the risk of having a little bit more slope movement activity when there is a lot of rock slope topographic relief present there. So if we were to kind of draw out kind of a cross section here across the big glacial valley there. Okay, we'll close that up, make our big tall peak there like that. Try to lay out the nature of the landscape here. And what I'm drawing right now, that's going to be that dangerous big mass of rock up there at the top. Start making our way down, and throughout this valley, it's going to have these really steep, sort of glacier carved walls down there toward the bottom. And all of the topography here is just really, really sort of steep and almost kind of knife edged. And we'll talk more about how that develops in a moment. But suffice it to say, you got plenty of steepness there. And like I said, I wouldn't be at all surprised if you're seeing some kind of a geologic boundary on the side of the slope there. And got to have our little glacier sitting up here, and the end of the glacier is actually kind of right at like a steep drop off on the slope right there. Put a kind of an ice blue color there on the cross section of the glacier just to show that it's different material. We should probably try to fill in colors there for the rock underneath it. So the concern here is that rockfall material from up here is pouring down and just covering the glacier there with a huge amount of weight. And because the glacier itself is, it's just sitting on this sloping rock surface underneath there. It's probably not situated to bear that weight without some kind of additional movement. And the fear would be that if you pile enough material up on this, you could end up seeing just kind of a large scale failure there that's going to take all of that ice out of there and send the whole 9 yards down to the bottom of the slope there at very high speed. And you're going to end up with a massive deposit of material that's going to take out anything in its path, and probably sort of fill in parts of the valley down there, just depending on how much material actually gets going. Another problem with this is the area there that we'll mark that in red. The area there that would be cleaned out by removing that big mass of ice, that could kind of undercut and destabilize the big block of material that is appearing to shift down slope, and you might end up with an even larger event developing there where you could slide a huge, huge, huge mass of material off the side of the mountain there. End up with some kind of crazy looking scar like that. And were that to happen, a significantly greater volume of material would end up piling up down there in the bottom of the valley. So in a situation like this, you have to keep in mind that the ice here is weight on the slope itself, but it's also kind of like propping up the slopes above it. So if the ice moves very suddenly, that itself can have a chain reaction effect for what's still on the slope. And also, if that ice moves suddenly, once it gets going down the slope with the rock mixed in it, it tends to help that sort of fluidizing process. So again, it's something that we don't see in the East Coast because we don't have the nature of topography that's necessary to do this to begin with. And it's absolutely something to be concerned about. How big is it? They talk about millions of cubic meters of material being involved in this. What does 1 million cubic meters look like? It would be pretty close to making yourself a cube. What would a million cubic meters of rock? Make yourself like a cube here that is like a football field in every direction. So 330 feet on the order of 100 meters in every direction. 100 meters times 100 meters times 100 meters to give you volume there. That would give you about 1 million cubic meters. Okay. This is 3 or 4 times that much. So it's really, 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 really big. Just using an American football field, there's a is a frame of reference because we don't tend to think in cubic meters. Rock like this per cubic foot, rock is usually in the 150, 160, maybe 170 pound per cubic foot range. So the scale here is it's quite something to say the least. It's not the entire mountain coming down. You have heard that reported, so it's not like the whole entire side of the mountain is on the move there. But if you were to remove that big mass that's been shifting slightly, this would be a highly significant event, even for this region, right? So the interplay between the rock fall onto the ice, how the rock and ice might move together, and then the fact that if you kind of leave that scarred area there where ice used to be, assuming that a large amount of ice and rock move, you further destabilize the mountain, makes it a really, really complex scenario. You can't get heavy equipment up there. The volumes are way too big. There's not any way to give it some avalanche treatment where you go and, with an explosion or something, try to move some of it. So really all you can do is wait and see. What's up with the overall topography here? Talked about the glacier being there. I drew a lot of topography without ice on it. In a place like the Swiss Alps, and kind of stylize the overall evolution of glacial landscapes here. We'll put a couple of mountain ridges here, and let's say we add some big glaciers that are coming down this valley here, and we'll actually send them up the slopes as well. Glacial systems tend to have sort of a system of almost like little side glaciers or tributary glaciers, if you will, and collectively all this ice sort of ends up flowing out of the mountains almost like water would, but really, really slowly at much greater volume and with really, really exceptional erosive power. So let's see if we'll color our blue ice there on all sides, just to show you the areas of the landscape that would have been ice covered in the fairly recent geologic past. Well, what happens if we get rid of some of that ice here? We'll color our rock into that may be useful here in just a moment. So we close up all the lines there. Nice. Okay, so let's get rid of our ice. Do my best to do this with the eraser. I should have just backed it up there and not colored my rock. But what are you gonna do here? So here our glacial ice is melting. We'll actually leave just a little bit of it up there in the top of that valley. We'll leave some behind in a few of these valleys. Actually, that might be a decent frame of reference there. Okay, cool, looking good. We'll do the pencil here. If you get rid of that ice, you're going to leave behind these incredibly steep walls going up what is now a very uniquely shaped valley here, and in areas that the ice has cleared away from sort of immediately afterwards, going to have these crazy steep walls left behind. And those steep walls are going to flank kind of larger kind of upland areas, if you want to call them that, in between the glaciated spots. So if we were to draw a cross section here, we'll use a red line for it and we can go something like that. The cross section would look like something like that with a really steep slope on either side of this big elevated area. And rock does not like that. Rock slopes need to have more of a shape like that, particularly when they're big at the large scale. So there's a reason that mountain profiles look like that in the Earth system. That is more stable in terms of the overall strength of rock. So when you have a landscape set up like this, it's really just tailor-made to have big slide events that will ultimately start to clean up the shape of that landscape, reduce the slope in it just a little bit, and bring it into a geometry that's a little more long-term stable. On top of this, places like the Alps, the rock is almost in some respect glued together with ice. So with changes in long-term climate from the ice ages to now, as well as the climate change that is going on today. Now, we're not talking about the source of that, but it is a statement of fact that average temperatures are rising in the Alps. As you start melting that ice away, that's quite literally removing almost the glue from this broken and fractured up rock on the mountain slopes, and that lets more water loose inside the rock, and that sort of greases things up as well. So it's a landscape that's unstable just for background reasons. And when you put shifting temperature patterns in there and you start breaking down some of the ice, you're going to end up with a potentially pretty dynamic scenario, and that's one for which the Alps are famous. Over the past just few centuries, there have been several absolutely enormous rockfall landslide type events in the Swiss Alps. So what you're seeing here is is something natural. The physical scale of it is not. It's not the whole absolute mountain collapsing, but the movement is in a really big area. I mean, you're looking at for the American viewers. I mean, it's going to be 1,000+ feet long, maybe 1,000 feet up the slope, hundreds of feet thick, or something like that. It's something that would be beyond just the size of a few houses or a few buildings or something like that up the mountain. You can compare that outline there to sort of the outline of the whole village of Blotton down there. So it's a big serious thing. It actually is possible in a place like the Alps to get like mountain scale slope movement events, but they would look more like this, where quite literally the whole side of the slope would kind of bulge outward just a little bit. Color that in right there. And it actually causes the summit of the mountain to sink down ever so slightly, and you get all these funny like cracks up through the top of the mountain there. That does occur. That tends to be a slower process. That isn't one that produces like a catastrophic type of failure like the concern is for in Blotton right now. But the takeaway here is that post-glacial landscapes are absolutely unstable, particularly when they're huge mountain ranges, and you always have to be on your guard for something like this happening. If you look pretty close at the rock here, it's pretty rough looking stuff. It looks to me like there's a pretty defined like a defined layering to it. I don't know how deeply this was buried. We think about the difference between metamorphic and sedimentary rock. That tends to have some impact on how the rock actually behaves. Not exactly sure what the answer is here, just from looking at it on Google Earth. But I would say that between that layered structure, you look at it from this direction, it looks like you can see a pretty well developed fracture system cutting through it as well. We'll mark those in yellow real quick. So between the layering, the fractures, it's rock that's able to break apart and fall apart really quickly. So it's going to be quite unstable on a slope like that. Dump it down on the glacier, and you have this chain reaction potential. So we'll see what happens here. I'm actually surprised that you're not hearing more updates on this. I don't know if that means that the situation has stabilized. Certainly, if there is a big movement here, it's going to be a big thing, and you're going to hear about it in all sorts of news outlets. So a lot of folks had asked me comment on this one. So that's what I got just looking at it remotely. But if you look for Blotton, Blatten, Google Earth will take you there. And you have to keep in mind that we're looking at it from the north, so you'll have to spin your view around to look towards the big mountain there. So I hope you found this video useful and hope you check out the next one when it comes along.